Stars don't lie. In this video I will show you how the starry night can help you understand the real shape of our Earth. In this video I use a simulation program called Stellarium. You can download it freely from the internet, so you can do exactly the same things I did. We are going to look at a starry night in the Netherlands, that's in Europe. We are looking above the northern horizon, and when we look there we see a constellation called Ursa Minor, a Little Dipper, and in that constellation there is a bright star called Polaris. We select it here, and Polaris is almost exactly above the North Pole. When we speed up the time, you will see that all the stars are moving around Polaris. Not exactly. Polaris itself makes a little circle around the North Pole. You can see it here. I put the mouse pointer on Polaris, and you see how it moves away from the pointer and moves back in a little circle. You have seen how this works, so we stop the simulation and put the time still, and we go to a different location on Earth. At first we go to the United States. You can see on the map where we are, and you see that above the northern horizon there still is the star Polaris, exactly as in Holland. And now we're in Russia. Polaris is again above the northern horizon, a little bit higher in the sky, but it's there. When we go to the North Pole, here above Greenland, we can see that Polaris is right above us, and this is an indication of the shape of the Earth, because when we go to the equator we only see Polaris just a little bit above the horizon. Some people will say it's perspective, but you can use it to determine the shape of the Earth. Now here's the flat Earth map. In the center there's the North Pole. Right above the North Pole is Polaris. Away from the North Pole is the South. There's not really a South Pole on the flat Earth. There's not one point that is the South, but there are many. We looked from Russia to the north and saw Polaris. We did the same from America and saw Polaris. And when we looked from the Netherlands in Europe, we saw Polaris too in the north, and it makes completely sense on the flat Earth as we look to the same point. When we looked from near the equator and from the North Pole itself, it was right above us. Now we are in the southern hemisphere in South Africa, and we are looking at above the southern horizon. Here we see a constellation called Octans, and in Octans there is a small star, a very dim star, Sigma Octans, magnitude 5.45, hardly visible with the naked eye, and it's there in the sky. It is almost right above the South, not completely. When we speed up the time you can see that Sigma Octans makes a larger circle around the South than Polaris did in the north. We stop the time and we go to another place on the Earth. We go to South America. In South America, we look at it in the southern sky. Sigma Octans in the south, and close to it the constellation Octans. It's higher in the sky because we are more in the south. Then we go to South Australia. Again, look in the south, and again we see Sigma Octans and the constellation Octans. Wherever we go on the southern hemisphere, we see Sigma Octans in the south. When we are on the South Pole itself, it's right above us. When we're near the equator, it is close to the horizon. Again, this is an indication of the shape of the Earth. And now we are going looking on your flat Earth map. We stand in South Africa and looked south and saw Sigma Octans and the constellation Octans in the south. Then we went to South America and looked in the south and saw again the same constellation and the same star on the same place, a little bit higher, but horizon. And in South Australia, exactly the same. And now's my question: how can we see the same stars and the same constellations in the south on the flat Earth? We are looking in 3 different directions. Now some may say, yeah, but you don't look really to the south when you're in South Africa. You look, in fact, to the same point as you are standing in South Australia. Let's look at that. Let's look if that is possible. I am standing in South Africa and I'm looking to the same point as I'm standing in South Australia. I go to South America and look at the same point. And what do we see? What do we see here? We see that it's possible. But there's one big problem. When I was a little bit below the equator, I couldn't see Polaris. And look, that arrow is much smaller than the arrow from South America or South Africa to the same point in the sky, and when we look from South Australia. And people, we have to accept that Galileo was right and the Church was wrong. Thank you for watching.